Hello everyone, this is Team 4TW. Our group project is US presidential election forecast and evaluation. Our team member including Junlo Lin, Huang, Ting-Yeh, Ting-Yeh, and Weihao Wu.
This slide is data preparation and modeling process. First step, we did data cleaning, like filling in missing value, deleting some sample with outliers, and high correlated predictors and near zero variables were also removed. And then we did data preprocessing by centering and scaling to improve the numerical stability of some calculations. Then we separate 18% of data into training set and 20% of data into testing set, and apply 10-fold cross validation on training set and implement 6 linear models and 8 nonlinear models. We also used cutoff method to find the optimal cutoff point for each model. After training all models and tuning their hyperparameters, we applied this trend model testing set to understand all models' final prediction performance.
The dataset we use is USA 2016 presidential election by county. We try to use this dataset to classify the background of voters in the United States. The dataset including 3,187 counties voters, background and systems including education, race, birth, occupation, health, and social problem. We can observe that the dataset has 53 columns including 1 character columns and 52 numeric columns. Data cleaning is a necessary step before analyzing the data to prevent the model from unexplained and lack of fidelity. We must clean out incomplete data before analyzing. The dataset we use contains 8,700 missing values that needs to be filled up, and more than 9,000 outliers needs to be dealt. The first step we took is to waive out the outlier. We use box plots to check at each column and deal with the outliers. We can see from the graph that after we deal with the outlier, there's zero outlier in our dataset, and the other graph shows the missing value in each column. The red histogram in the graph shows the number of missing value, and it's more than 8,000 missing value in this dataset, and we use median to fill up the missing value and compare with the previous graph. We can observe that all of the missing value in each column filled with the value, and the graph shows no red bar in our graph. The next step we take is exclude variables whose variance is 0. We use near zero variance function to check which variable needs to be deleted. The result shows that injured deaths are near zero variables, so we delete the columns, and the next step is to finding out the high correlation columns and waive these columns. We can observe from the chart below shows that there are 12 columns have high correlation. In order to keep the linear independence, we exclude these 12 columns.
This slide is the summary of linear classification model performance. And the plot on the right is RC curve of all linear classification models. And linear support vector machine has the highest AUC value, and logistic regression has the lowest AUC value. Although we remove several predictors with high correlation, there are still too many features which might make logistic regression face the problem of overfitting and multicollinearity. So we apply penalized logistic regression to reduce this problem. Penalized logistic regression can also regulate models' behavior by a penalty term. For the penalized logistic regression, alpha value is 0.2. It means this logistic regression combines 18% of range regression and 20% of lossal regression. And as we can see, accuracy is enhanced and RC curve is obviously improved. We use LDA to reduce dimension by extracting effective features. And Sparse LDA is a penalized version of LDA, but it performs worse than LDA because it has penalty term and did not reduce any predictors. The best tuning number of variable is still 14. PLS also performs well, but is still worse than linear SVM. Linear SVM performs best compared with penalized logistic regression, PLS, and other linear classification models. It has the highest accuracy with 94.28% and highest kappa with 79.66% and highest AUC value with 97%. The optimal number of cost is 16 and sigma is 0.0378. This page shows the model performance against the number of tuning hyperparameters. And we tuned hyperparameters with the highest accuracy.
This slide shows the nonlinear classification model. We can observe that compared to the linear classification model, the nonlinear classification model performs better. In the nonlinear classification model, the performance of k-nearest neighbors and basic classification trees is significantly worse than other models. The random forest has a better performance than other models with accuracy equals to 0.9498 and kappa equals to 0.8228. This slide shows the nonlinear classification's hyperparameter. All models will show oscillation before finding the best hyperparameter, and some will oscillate even after finding the best parameter. Therefore, we can note that the number of parameters does not represent the quality of the model, but to find the best suitable parameter.
In the following, we are going to implement both linear and nonlinear classification with cutoff method of the optimal cut point from RLC curve. The RLC curve is a mapping of the sensitivity versus 1 minus specificity for all possible values of the cut point between cases and controls. RLC analysis provides two main outcomes: the diagnostic accuracy of the test and the optimal cut point value for the test. Cut points dichotomize the test values, so these provide the diagnosis. The identification of the cut point value requires a simultaneous assessment of sensitivity and specificity. A cut point will be referred to as optimal when the point classifies most of the individual correctly. In linear classification, we get the performances of each models with their corresponding hyperparameters under cutoff method. The result shows that among all linear classification models, linear support vector machine has the best performance with the accuracy of 0.9262 and the kappa equals 0.7313. However, logistic regression shows the relatively bad performance among all, due to the collinearity. In nonlinear classification, we get the performances of each models with their corresponding hyperparameters under cutoff method. The result shows that among all nonlinear classification models, random forest, backtrees, and gradient boosting remain relatively good performance with the accuracy of 0.94.